third video for linear programming. This one just has the one problem in it. The area of a parking lot is 600 square meters. A car requires 6 square meters and a bus requires 30 square meters of space. The attendant can handle up to 60 vehicles. If a car is charged $3 and a bus is charged $8, how much of each type of vehicle should be accepted to maximize income? What's the problem want to do? What's our objective here? If you said maximize income, you are 100% correct. That's what we're trying to do by the time we're done with this thing. Now, what are my variables? Well, what does my parking attendant want to know? He wants to know, or she wants to know, how many of each type of vehicle. So let's go ahead and highlight that. How many of each type should be accepted? So there's your variables. You got to tell them, well, you need this many cars and this many buses in order to get your income. So that's what our variables are. So X will be the number of cars and Y will be the number of buses. Now I did something different in this problem than I did, I think, in the first problem. And that's I put in a different constraint. And I'm going to just show them here. I have X is greater than or equal to 0 and Y greater than or equal to 0. I did not show that in the very first problem I did, and I should have back in video number 1. It's sort of, I get the students look at me and say, yes, Captain Obvious. Of course, you know, he's not going to accept a negative number of cars and a negative number of buses. To be completely correct, we need to make sure we're constraining things to the first quadrant and that we're, you know, not going to be less than 0. It sounds kind of stupid, but it's just mathematically correct thing to do. Okay, let's list our constraints here. One is that the attendant can only handle up to 60 vehicles. That 60 first vehicle is not going to be accepted. So the number of cars and the number of buses has to be less than or equal to 60. He's also constrained by how big the lot is. It's 600 square meters, and each vehicle takes up a certain amount of space. A car takes 6 square meters and a bus takes 30. So 6 times however many cars he takes in is going to be the space that the cars take, and 30 times however many buses he takes in is going to be the space that's taken up by buses. So space taken up by cars, space taken up by buses has to be less than or equal to 600. He doesn't have any more room. He can't go over 600. So let's get our constraints graphed. Now, what I did is for the first one, it's probably pretty easy just to graph the intercepts. And most folks can see for this blue equation here, if I set X equal to 0, Y is 60. And if I set Y equal to 0, X is 60. So that's the easier of the two equations to graph. So let's do that first. So that's my number of vehicles, and whatever combination, I can't go beyond that. I can't have more than 60 of them, so I know I'm going to be below this line right here. Now, with this red equation, I went ahead and graphed the intercepts. I set X equal to 0 and found the matching Y value. I set Y equal to 0 and found the matching X value. For me, that just seemed like the easiest way to go. So when X is 0, Y is 20. And when Y is 0, X is 100. So there's those. Let's go ahead and put our red line in for the space constraint. And that's that one. And again, there's not more space to be had, so he's got to be below this line. Now, where is your feasible area? Where are you less than the 600 square meters and less than the 60 vehicles? Well, it's going to be this area right in here, bounded by the red and the blue. So that area right there. Okay, notice I didn't really do anything with these. I just put them in there. Let's put our dots on so that we've got our vertexes. So we're at 0, 0. We're at 0, 20. We're at 60, 0. And then we're at some unknown amount where those two lines intersect. Now, I said we're at 0, 0, and we do test 0, 0 because there may be the odd reason why it makes no sense for this business. If they're going to lose money every which way, maybe it makes sense to just say don't do your business. So we do test it just to prove it out. 0, 20 is that point right there. 60, 0 is that point. What's this point right here? Well, I went ahead and I took our original two equations back up here and I put in equal sign because I'm just going to try and solve them for a point. I'm not worried about shading. So I have x plus y equals 60 and 6x plus 30y equals 600. And I'm going to solve them using elimination. So I wanted to get rid of the x's. So I multiplied everything here by a negative 6. So that'll give me a negative 6x. Those, when I add them in columns, then I get 24y equals 240. Divide by 24, y equals 10, so x equals 50. So that's where this point came from. It came from this algebra over here. So take a look at that, make sure you understand it. Now, our objective function. What was our objective? Let's go take a look. Why are we doing this problem? Well, we're trying to maximize income. So let's take a look at income. A car gets charged $3. So 3 times however many cars he takes in is how much money he'll get from cars. A bus is charged $8. So 8 times however many buses he takes in is how much money he'll get from buses. So here's our objective function. Income is going to be 3 times x plus 8 times y. Now I take each of these combinations here, all of these points, because each one is an x and a y, and I put those in the function there. And you have to do them all. That's the rules. So 0, 0. You put in zeros for your x here and your y here, and you find, no surprise, you get no money. The point 0, 20 right here. I put in 0 here and 20 here, and I wind up with 160 bucks for the guy. 60, 0, that's this point right here. 60 in here for x, 0 in here for y, gives them 180. And then the 50, 10, which was the point that we had to solve for right here. That's where this math came in right there. Plug in 50 for x and 10 for y, and that's $230. So how many of each type of vehicle should he accept to maximize the income? 50 cars and 10 buses, and his income will be, or her income, $230.